operations and solve some equations now. And we're not going to do our one-step, two-step equations. We're just going to mostly do our equations mentally after we get them simplified. And we'll see that here in a second. So a couple definitions. Open sentence. Well, in math, an open sentence, it's basically just anything that contains a variable or expression with variables. So an example of an open sentence, 3x minus 2, right? Because I can't evaluate that. There's no value for x yet. So it's open. That's why I say it's an open sentence. And then an equation is a sentence that contains, well, the core of the word equation is what? Equals. So it contains an equal sign. So now this expression up here becomes an equation once I put an equal sign on it and whatever we want to set it equal to. And now I'd be able to solve for x here, but we're not going to get that far into that. We're just going to do some easier ones that are mental to get through, but we just got to follow our order of ops first. One more definition, solving. Whenever it says to solve, we need to find a value for the variable that makes the sentence true. Okay, and this value is called the solution. So for example, if I had x plus 4 equals 8, right? What number plus 4 is 8? Well, 4 plus 4 is 8. So 4 would be my solution for x. That's all I'm saying when we solve. We find the solution. Okay, pretty basic. This is what I'm talking about. Here's my equal sign. Okay, right here. Got my equal sign. And I'm saying this whole left side is equal to b. So basically, I'm just going to evaluate that left side, and that'll solve for b. I don't have to do anything else besides simplify this left side. So let me rewrite this so I get a little bigger. 3 plus 4 times 2 to the third minus 2 equals b. Okay, so just kind of work straight down. So I'm going to start inside my parentheses, follow my PEMDAS, right? Once I go inside my parentheses, I got to do exponents first. So 2 to the third power is 2 times 2 times 2, which is 8. And then stay inside my parentheses, right? I'll follow the order of ops. 8 minus 2 is 6. Might be a good idea to rewrite this. Okay? You get into mistakes if you try to work too fast and skip ahead. But if you keep rewriting after each step, you'll be okay. Because then I look, well, after parentheses, I do exponents. Don't see any exponents. Multiply and divide next, according to our PEMDAS. Well, I have multiplying here, 4 times 6. So I have to take that first, which is 24. And 24 plus 3 is 27. So b equals 27. And I can write it like that, or I can flip it around. It doesn't matter. Okay, I could have left it just like this, because I know that it's symmetrical. So b equals 27. All right, you're just simplifying, going through your order of operations. A few more. Let's go look at number 1 here. Okay, now the variable isn't by itself anymore. Here's my variable. I got a bunch of other stuff on the left side with it. So let me just go, let's just start simplifying, right? So let's go inside our parentheses, follow our PEMDAS. I can take my 3 squared, 3 times 3, which is 9. And now I got to work inside my parentheses. So bring my 4 plus down, and 9 plus 7 is 16. Well, I don't need to keep it in parentheses anymore, right? Because I got that plus sign right there. So it's just plus 16. And I got to bring down my divided by n equals 8. Okay, once you get to this point, don't make the common mistake of adding 4 and 16 together. A lot of people want to add 4 and 16, but I can't do that because order of operations tell me I have to do 16 divided by n first. Well, since we don't know what n is, let's just stop at this point and see if we can solve for n. Let's see if we can figure this out mentally. Okay? Well, I need this whole left side to equal 8, right? Because the right side equals 8. Well, let's think here now. Since I got to do 16 divided by n next, I got to think. I got to get this to something where when I add it to 4 over here, it's going to equal 8. Well, let's think about that. 4 plus 4 equals 8, doesn't it? So I got to get this 16 divided by n to equal 4. Well, what can I put in for n to make this whole thing be 4? Well, 4, isn't it? 16 divided by 4 would make this whole thing 4, and 4 plus 4 gives me 8. So you just got to do that last part mentally. Do that last part mentally. Look at number 2. Follow your PEMDAS. So do all your parentheses first. So 12 plus 2 is 14. Might be a good idea to rewrite this left side now. 4n minus 14 equals. Now let's do the right side. Do the parentheses first. 6 minus 2 is 4. So I got n times 4. Well, I don't want to write it as n times 4. Anytime we have a variable times a number, we always write the number first and just put them together, right? 4n. And we still have our minus 9 out here, so let's bring that down, minus 9. Well, what do we notice about the left and right side? They both have a 4n, and one says minus 14 and one says minus 9. So if I think about this 4n is the exact same thing, right? So they almost kind of cancel each other. They don't even really matter, okay? And negative 14 does not equal negative 9. So let's go back to this point here. So basically what we're saying is there's absolutely nothing I could put in for n that's going to make this statement true. So there is no solution, right? I can't say n equals anything because it will never be true. So we say no solution. No solution. Okay, and let's hold that thought. After we do number 3, we'll come back and look at that a little more. So number 3, same thing. Follow your PEMDAS, get this thing simplified. So go inside my parentheses. We're looking at the left side here. I got to do my division before my addition. So 8 divided by 4 is 2. And 5 plus 2 is 7. So I'm going to rewrite this now. 7 plus 3k equals, well, I can't take k plus 32, but I can distribute here, can I? 3 times k and 3 times 32, which is 96 minus 89. And I can still simplify that 96 minus 89. So I got 7 plus 3k equals 3k plus 7, right? 96 minus 89. I can simplify that. Well, let's look at here. 3k is the same. The 7 is the same. So it's the exact same on both sides. So no matter what I put in for k, this statement's going to be true. If I would put a 1 in for k and a 1 in for k, right, I'd end up with 3 times 1, which is 3, plus 7, which is 10. Okay, and that would be the same on both sides. Even if I would put a 2 in for k, I would end up with 6 plus 7 on both sides. And it would still work. So over here, everything works, right? Every single number I'd put in work. So we say all real numbers. So every single solution would work. So every real number would work. K could be anything, right? So we say all real numbers for that answer. So if you think about it, compared to number 2, where there's nothing I could put in for n, right? Because the negative 14 and negative 9 are different, so there's no solution. Whereas number 3, they're the exact same on both sides. So now everything is a solution. Okay, those are the difference. And we call this the identity property as well. All real numbers is perfectly fine by me. If you want to say identity, I'm okay with that too. But every number would work for 3. Also, we're going to get some story problems. Basically, what I want you to do is bring in a variable into play before you solve this. So let's take a look at an example here, because most of you could solve this without a variable, but it's good practice, right? So Jennifer pays $16 per month for a gym membership. In addition, she pays $2 per Pilates class. Write and solve an equation to find the total amount Jennifer spent this month, but she took 12 Pilates classes. So a lot of people are just going to take your 12 times 2, right, because that's the cost of that, and then add on that 16. But let's write an equation here first. So if I think about it, the total cost, let's come up with an equation for our total cost. Let's put P in for Pilates class. So let's let's say we didn't know how many classes she took, right? She pays $16 a month plus 2 per class. So 2P, right? 2 times the amount of classes she took. So there's my equation. And now it's telling me to plug in 12 for P, which would give us 16 plus 2 times 12, which is 24. And 16 plus 24 is 40. So she spent $40. Okay, so I know you could solve this without writing this equation. It's good practice. It'll help you out later on if you can get used to defining a variable and then writing an equation. But if you can come up with this $40 without writing an equation, I'm also okay with that. But it just get used to bringing in that variable. And when we have to do it, you'll find out that'll be a lot more helpful. Same thing with here. Amelia drives an average of 65 miles per hour. Write and solve an equation to find the time it will take her to drive 36 miles. Well, here's the thing. We have miles per hour, which is a rate. And we have miles, which is a distance. and we're trying to find time, aren't we? Okay. Anytime you have distance and time, or distance, rate, and a time, there's a formula that we use. Okay. I like to call it the dirt formula. Okay. Now this dirt, it's actually mathematical dirt, because this is how I spell it. Dirt. It's not like your normal dirt. This is mathematical dirt, because it stands for distance equals rate times time. Right? Distance for D equals for E, rate, time. Distance equals rate times time. That's our little mathematical dirt. That equation we can use for any time we have a distance, rate, and a time. So I look here, I'm going to use that equation, that formula, and plug in information that I know. So do I know the distance? Yeah, it took her 36 miles to drive. So 36 for D. The rate I know is 65 miles per hour. So 65 for the rate. And I do not know what the time is, so I leave T. Right, so our distance was 36. Our rate, we said, was 65. T, we don't know. And now I can solve. So I'm saying 65 times what is going to give me 36? Well, here, this is where we need to apply our one-step equation, right? To solve for T, going back to last year, we do the inverse of multiplying by 65, which is dividing by 65. So our 65s cancel, and T would equal some decimal. And we can just round to the nearest tenth or nearest hundredth. It doesn't matter, it doesn't specify. So we'll say 0.55, and what are we in? Hours? So let's put a label with that, 0.55 hours. And there you go.